in there. Feel free to sneak off if you need to through the talks. Drinks, I think you've all found them. Fridges over there if you want to sneak a beer. They're over there, the nice pale ale, I think, at the moment. Fire escape, just to where the toilets are, just keep running through there. You'll see the fire escape sign as well. So sponsor for the event space, so Intane, they help provide the venue, the drinks and everything for tonight, all the AV gear, and the boys help set it up. So big thanks to them. And of course Mantel for helping to provide the food. So we all love pizza. So yeah, big thanks to our sponsors who help make it happen. Finding us online, if you haven't found us online already, please join the Slack group. The Slack group's where a lot of community is. There's jobs posted on there. There's different meetup groups for the different chapters and the different areas. And it's a great community resource that you can sort of lean on and help with any questions. So some of the best, brightest minds in the iOS community are on that, or pretty much all of them are. So yeah, really great resource to tap into, and like if you've got a particular weird issue, I'm sure someone can help you out. Upcoming events, we've actually got someone coming up from Melbourne, which is really exciting for the next one. So because we're a small scale meetup event, we do have sponsors, but not sponsors with budgets big enough to fly people up and put them in hotels. He's actually doing it out of his own pocket, which is quite cool. So he, on the sort of similar tone that we've been having recently with some of the game engineers, like indie engineers, he's an indie game dev. So the talks make, build, ship, learn and move on. So it's sort of about, learning to actually ship your code and learn from it, and not try and perfect everything before go live. So that's going to be really exciting. After that, Gwen is going to be doing a talk on writing better native code. So a little bit of a talk similar to tonight. And Clifton is going to do one on local models. So there's been a lot of interest relating to this, and sort of a bit of a spin-off of what Josh has done recently with some of the on-device stuff. Because yeah, there's certainly been some big breakthroughs really with local models recently, and it's sort of not catching up, but like it is certainly getting closer and closer, and sort of something that you can actually start to use now. So yeah, a few interesting talks coming up, and if you are interested in doing one as well, even if it's a short one or a half one, please reach out. You can find me on the LinkedIn or come chat to me at an event. But yeah, would love to have you speak at an upcoming one. So who am I? I started my career as a web developer because why not? Web seems like an easy thing to get into. So I did like freelance for a bit, doing websites for people while I was in high school. Then I went on and actually started working full-time doing brochure sites and CMS sites while I was in uni. And then I found that I didn't really need to go to uni because I was just go to work and I was learn like 10 times as much. And then it's like that month-long assignment takes like half an hour. It was quite good. So that's how I started my career. From there, I went to an agency. So this is the largest, I would say, app agency in New Zealand. So I took a role there as an iOS engineer. I always wanted to get into iOS. I've been watching WWDC nearly since right from the start, since I was a little wee kid, and knew nothing about what coding meant, but just loved it. Seeing the announcements, it was so cool. So I knew I always wanted to do it, and an offer came up. So I took it, got in, so excited, and they're like, so you're a web developer? I was like, yeah. And they're like, how do you actually feel about being a web engineer? And I was like, well, I really took this job because I want to do apps, particularly iOS. And they're like, we actually really need some web work. So then I got roped into doing web there for a bit. And that was cool. I got to go at building web apps at scale. So I helped build MetService, which is the BOM of New Zealand. Really cool website, about 10 years ago probably now. Probably come in at 100th of the budget of the BOM website, pre-AI, and probably about 100 times better as well. So that was a really cool project, doing a sort of large-scale web apps, because there's a lot of there. And then eventually I got the call over to go over to native, so I helped build the brand new Flybys app. This is AI's wonderful job of removing the white from it, and it decided to add an arrow in. I don't know why it wanted to add an arrow, but just wanted the white gone. I thought that'd be simple, but yeah, I had to get a few logos going, and then it degraded me to like the V1 image experience. I think I must have been throttled a little bit there. But helped build out the new Flybys app, which was sweet. Worked on different media clients, so the two largest media clients in New Zealand were through the same agency, which is kind of funny. same people hopping between them. So it's TVNZ and MediaWorks. Did some banking stuff, did an app that taught young New Zealanders how to drive. Went back to Met Service and did some stuff on the Met Service app as well, and utility apps and whatnot. And that was actually really cool because there was some really smart leads there, and every lead approached it differently, and they would build an app a year later and do another one. And this was early days in the app space, so it sort of taught me, here's 10 ways you can build apps, here's the bits that I like from that, and that. And every time a new one was done, the lead would do it differently and incorporate bits of them all, and people moving around and incorporating ideas. And that really accelerated my career because I've had mates that went into banking sectors and it's like, oh yeah, we just do this because it's Objective-C and we started this like 5 years ago or 10 years ago, and that's all they know, or they just were responsible for changing button colors or something, or fonts or whatever it was. So that was a really good kickstart to my career. I then went to a startup. During COVID, I got an offer of going and joining a company to help roll out a contact tracing solution. So we built a COVID contact tracing card, which was really cool. It was a small local company in Wellington doing safety features, and then it ended up going international, and that got rolled out to lots of huge companies like the likes of Toyota, Hollywood, etc. And the company went from being worth like a few $1 million to close to 100. So with a nearly 1% stake in that company, I was like, that's pretty awesome. I think there's like one person or two people working there now. I don't think too many people are interested in contact tracing solutions. But that was a really fun time. And then they also had a core safety offering as well, which was a Ionic V1 Angular. So like React Native's like up here, like that's like below the floor, like basement level. And they were trying to migrate that to native, and then I sort of like, hey, like let's scrap this plan, let's go and build it natively. And they're like, okay, ended up managing to convince the CEO, we got the funding, we went ahead and did it, hired a whole bunch of people, got in, and then like, well, it was your idea, so now you're responsible for this. So I was like, I've never like led something like this before. And like, well, you're doing it. So I was sort of acting as like a delivery manager, like product owner, like head of mobile, like engineering, like on the iOS side, like, yeah, there was a lot to be learnt from that, and sort of managing people as a lead, managing projects, yeah, really taught me a lot, and was probably one of the nicest code bases I've actually ever worked on. It was such a cool one. It was fully offline first, so you could do anything, everything loaded immediately, and then as it would, the data would fetch, it would come in, like the level of testing, it was, yeah, really cool project. From there, I moved to Australia, joined a little company called the ABC, so a bit of like government enterprise level. So I joined and they were rebuilding ABC Listen. They just sort of started and then came in, and I was like, well, it's probably not how I'd build a brand new app. And then heavily influenced the direction and sort of changed that and reworked a bit of what was underway. Built out the team, grew a lot of people there and stuff, sort of brought in a lot more modern practices with how you do apps, which was really cool. And then, sweet, so now I sort of started to oversee the audio side there on iOS, and then audio and news as well, and that was across iOS, and then towards the end I was iOS and Android for both, and then I was like, oh, this is so much, like too many apps, too many people, there's like millions of users, and it was just like meeting to meeting. But yeah, it taught me a lot about sort of working in that government enterprise, which is very different to a startup and which is very different to an agency, and multi-app architecture, because we have a lot of similar apps that want similar functionality, but we don't want to have separate versions of them, and certainly didn't have budgets for that. Now I am in the gaming industry, which is here at Entain. So for those of you that aren't aware, there is Ladbrokes, Neds, Tab and Betcha, so a sort of cohort of gaming applications. It's a white labelled application that sort of reskins in the different colours and fonts and themes, goes to the different stores, and I'm a platform lead here. So as I mentioned at the start, a lot of my work recently has been around influencing the architecture direction, and I've actually been using AI to sort of help rework it and change it to just sort of address some problems that are now starting to seep in. Now we're scaling up and getting pretty close to the 1 million lines of code. So yeah, that's a little bit about me. Bit of my background, I've got a bit of experience now in migrating apps from hybrid frameworks to building new ones to using legacy Objective-C. Yeah, I think each sort of part of that career has sort of gotten me to a place where I'm somewhat credible to now talk about app architecture. So to the talk. Who remembers Model View Controller? Yeah? Yeah. Model view controller. Nah, it was massive view controller. So everyone knew that, right? They're like, man, these controllers are so big. They're so big. There's so much going into them. How do you test them? It was such a pain. And people were like, how can we solve this? And then this new thing come along. MVVM, like the bullet, silver bullet, right? This is going to fix all our problems. This is like, this fixes your problems. But yeah, I personally like to call it like my view's very messy or massive view model. And you know, I've seen a few code bases now, and they go to it, and their view models are massive. You know, it's like, cool, we fixed it by taking it from this thing and moving it to here, and it doesn't really solve any of the problems that people thought it would. It's just like a relocation or a way of splitting it out. Is my personal view. While it can solve your problems, I think most of the time it becomes a bit of a dumping ground. So, what is a view model? This is actually Google's answer to what it is, and I know we're an iOS meetup, I haven't forgotten the room I'm speaking to, but Google actually has really good definitions on architecture and guidelines around building things. Apple doesn't. Apple's like, do whatever, use MVC, like do whatever, just put it in the view, like it's fine. Whereas Google's like, here is exactly what you should do. And what it actually does is it creates two worlds where iOS doesn't really have an alignment, and people just doing whatever and trialing all these different things and coming up with their own solutions. It creates different ways of handling it, which is really good, but there's not really necessarily great alignment on that. Whereas I find Google is like, here's how to do it, and people are like, this is the Bible, I must abide by this, there's no way you can deviate from it. If you do, you are not following the correct architecture guidelines. So this is actually for extract from Google, but it says the view model class is the business logic or screen level state holder. It exposes state to the UI and encapsulates relating business logic. So what should it do? Represent the view state. It's a view model. Models the view. State for the view, please. First and foremost, liaise with other objects possibly to fetch data and perform actions with it. And ideally, follow the single responsibility principle. So ideally, it's a good principle to follow, is to have a single responsibility. Does it though? I don't think so. It seems to be doing quite a lot when you look at code bases. Regardless of where you are or who you talk to, I think everyone falls into the same trap. So what shouldn't it do? Actual fetching and persisting. It's a model of the view. It models its state. It's got nothing to do with loading data from a database and caring if you're using GRDB or core data or Swift data or GraphQL or what version of Apollo you're using or anything. It's got nothing to do with the view. Like it's the view. It should be UI. Polling of data. Putting polling of data into the UI is generally not good practice, because then you enter a screen and it may start polling and then you leave and it becomes outdated. Or if you have two tabs and they're both polling independently and then get out of sync, it's not particularly great for that either. Analytics. Analytics always seem to fall on them, usually because it has state and you need that to comprise the analytics event. But it's got nothing to do with analytics. Navigation. This is a good one. More often than not, navigation will tend to route through a view model because it has access to some kind of parent coordinator or state management system. Yeah, I don't think it should do that either. UI shouldn't have anything to do with UI either. Like on the Listen app, we set it up in a way that we had UI kit and then they migrated to Swift UI, and you didn't need to actually like change anything in the view model. It was completely UI agnostic with what it's doing. On that one as well though, that's also a really good one, so it can sort of share with different implementations. So technically you could share the same view model with, say, if you had different layouts for like iPad or iPhone, or if you had, wanted to A/B test something with like a UI kit, and then Swift UI, or, you have a Mac UI or something like that, you can sort of share the same state because it shouldn't care what the UI is actually doing. And complex business logic. I think the view model may want some level of business logic, but definitely not too complex. So, how can we minimize this? Creating helpers and extensions. Please not on the view model. Please, I'm begging you. Please don't just create another extension on the view model and make it in another file and be like, cool, I've fixed it. Like, you're not doing anything. You may as well just have it in the same file. But yeah, creating them Swift is a very nice language, I think, for providing functionality. So I'll walk through a demo later, but for instance, like if you wanted to toggle something, you might have an extension that can go and look through and like toggle that value, for instance, or finding things in an array or things like that, mapping things. These are all really good in extensions, and then it makes really nice inline syntax rather than having that gist of the code copied everywhere. Helper classes are really good. For instance, you could create an enum. Enums, because you can't actually instantiate them and create them. You can have static functions on these, and you can sort of go and build out helpers. These are really easy to test as well, because you're not instantiating anything, providing it with state. It's like, here's an input, give me an output. That's like the easiest thing to test, right? Minimizing the number of intermediary objects between caller and receiver. So this one's one that often sort of creeps up, as well as like if you have something that happens at like an app level coordinator, and then it's like you want to call it in a button, and it's like that view calls a parent view, which calls a parent view, which calls a parent view, which calls like a view model, which calls like a coordinator, and that calls like a parent coordinator, and that calls like the app coordinator. Like, yeah, I want to add another thing in here, and now I've got to go update like 10 function signatures and like pass it through, and you're like compile, and it's like waiting, here as well, compile, waiting. It's like quite a painful thing to do. So using good forms of dependency injection to sort of provide that bridge a little bit more seamlessly, where you can just like, sweet, add it in here, call it, done. That's a huge game changer. So as I mentioned, that comes from making good use of dependency injection and considering where the code actually lives. Is this something that relates to the view model, or is it just convenient to dump it in there? So actually thinking about these things before you just sort of extend on what's already there is quite important. So, real world demo. Let's fix an app. So, live demos always go good, right? What goes wrong? I haven't even compiled this. No, I have. I made a restaurant app. I didn't make it. I didn't actually make it. Claude made it, but I made it. So this might be something that you see in the real world, right? You've got a restaurant finder. You've got a list of restaurants. Presumably, you need to fetch these from somewhere. You have some cuisines, so you can choose cuisines, you can choose price levels, you can filter whether it's open, the rating, you can sort it, and you've got a list and it's got some UI. Like, there's a fairly like sort of typical screen. I didn't want to do like a super crazy complex screen where no one's going to understand anything, but I also don't want to sort of do what Apple might be prone for doing sometimes, and they show you, wow, look how simple and easy this is, but it's like super basic, and you're like, no app actually looks like that, right? So this is somewhere in the middle, right? Here we've got an app. These should be packages, but for the sake of a demo, they're just not. They're just folders. But we've got some core set of things here. We've got an app, which is a high level, which brings everything together. I'll get into the principles of this a bit later. We've got some views. Within the views, we have components that are sort of core, and then we have a restaurant list screen. There's only one screen, sorry. And then some core models which are used to represent the domain, and then we've got some services. So you can see we've got analytics service and restaurant service, so for sending off the analytics and fetching the restaurants in there. So that's sort of like a basic little app to show for this. But what I want to sort of focus on is like the gist of this. This talk's not going to be about UI at all, and it's going to get into the larger architecture. But where I sort of see a lot of the code and apps going, where it shouldn't necessarily actually go, is within view models. And what often gets dumped into the view model is like the core of an app, when you're thinking about all of the analytics, the navigation, the state, business logic, like fetching the data, storing it, stuff like that. So in here we can see we've got a main actor observable view model. We've got some functionality injected which can fetch restaurants and give us a list. We've got analytics service and a navigation service. So fairly sort of typical dependencies that would be injected. You have a list of restaurants and some view state. So you can see here it's loading or it's loaded, errored, stuff like that. We've got then some user-driven things, so around the filter criteria and sort options. And then in here you can sort of see some computed properties. So you can see here we've got some code which fetches the available cuisines. Looking at this, one of the obvious problems is that given the Swift UI, it will read this a lot. So every time the view body executes, which happens a lot in Swift UI, it'll ask what are the available cuisines on the view model, right? And then it has to recompute this. So say if restaurants was a really big list, it has to go through that every time. Whereas when it's a stored property, it just goes, cool, here's your property. So that's one thing to sort of be aware of in terms of performance on SwiftUI. But you can see some more like outdated sort of ways of programming in here where we've got like a list here, we're like going for I and this, we're sort of got some different state that we're then setting to true. If a condition matches, we're checking if it's not already in there and adding it, we're sorting it, stuff like that. Sorting is another one to be aware of on something like this as well, because sorting is a lot more expensive. Similar thing here where we've got quite a large function, so you can see in here like, whoa, we've got a bit going on, mate. And again, this is on a computed property, so that's not good either. But the idea of this is we're getting like a filtered list, right? So we create a list, we loop through the list, checking if it should be included, and if it sort of shouldn't be included, we set it to false, and at the end it won't add it, otherwise it'll add it. But the issue with this is like if we want to test this, we need to create like a big list of restaurants, then we need to create a view model, then we need to sort of like inject this into the view model somehow, and then we need to then make sure it's loaded and set, and then we can call this function, and then it can sort of test the logic. So all of this logic's actually a little bit more difficult to test. And another thing with that, being a view model, it's isolated to the main actor. So imagine you have like millions of test cases, and the test case is like, cool, I'm going to create a view model, but I need to do that on the main thread. You've created a bottleneck, right? My computer has 14 cores, but now it's almost running sequentially because I've isolated it to the main thread. So that's another reason why putting complex business logic into an isolated class where it has to run on the main actor or it has to run on the main thread isn't particularly great. Whereas if it was non-isolated, you could call it from anywhere, and you can get that true parallelism, which is quite nice. You can see we've got some navigation function, we've got some loading function, some refreshing functions, some filtering stuff, clearing, toggling filters, toggling price filters, and we've got some ordering in which this sort of we want to show it. So I think this is like fairly sort of standard for what you see, but can we do better? We've done better. We've cleaned up the view model methods. So just showing you in here, what we've done now is we've gone from this sort of complicated logic here to now we have created a set of restaurants because we want it to be unique. We turn it into an array and we sort it. So that is sort of relying on system level functions, and it's also working in a functional way where you go through the list of restaurants, map it to a cuisine, you're using the native set, and then you're sorting it. So you go input, 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 expands out, and we're not having to like manually like traverse through the list there and do it. Now we'll go to the filtered and sorted, and you can see there was a lot in that function, right? Now we've got a filter by function. So given a list of restaurants with this criteria, please give me the filtered ones. And then we have another function which is sorting them. So now we're starting to like break this up. It's good. We like breaking things up. Loading data. Now we've got a generic perform load, so we don't have similar stuff across the load and refresh. So that's looking good. We've still got our analytics event in there. Where sort options not too different, fairly similar for now. Tidied up the filtering a little bit. And here, this is an example that I was talking about where we now have an extension which can do, on the selected cuisines, we can toggle it, which will invert it, rather than having to have logic like this. We've got our perform load. So now looking at that, it's really easy at a glance. You can see like how simple it is, and then we can reuse that with the other functions. We've got some filtering in here as well. So again, given this list of restaurants with this criteria, give me a list. So we have input, input, produce these together, give me an output. That's really, really nice because it's not reliant on local state. Whereas if you are reliant on local state, if imagine it gets changed midway through, or depending on that state has a different value, you can get different outputs, right? So when you create code in this way where you sort of give it a set of inputs and then you get an output, it's a lot more deterministic, but it's also much easier to test. So you can see we're sort of, again, using some nice Swift operators, and these Swift's beautiful for these compact maps and filters and first index of. Many other languages don't have them. So to filter it, and then we've got sort of a bunch of filters here where you can go through, and each of these do a specific thing. So going back to that single responsibility principle, it's really easy looking at this. I don't need to understand the code to understand what it's doing, because it says matches search text, matches minimum rating, etc. This is really, really easy to understand. And if I want to understand how it's matching search text, I can just click on it and go to the, like, look at that specific detail. But given I'm looking at the filtration system, like I don't care about the inner details, I just want to look at how is this filtering the list. Okay, and then I can dive into what bit I'm interested in. Now we've got like sort of small modular functions for each particular thing, where it's doing the mapping, sorting, filtering. So yeah, and again, utilizing some system operators. So it's starting to like break it up. So we're getting a little bit better now. We're using nice level system operators. We've broken our code up. It's a lot more readable. We've reduced some duplicate code. We've simplified it a lot. So a lot easier to understand. Can we do better? Hopefully we can. So now we're going to introduce the concept of a repository. And I call it a repository. Some people might call them use cases. Some people might call them stores. Like, you can call them whatever you want. You can call them providers. It doesn't really matter. Like, they often come with a different name, but essentially just do the same thing. So let's have a look at our restaurant list view model now. You can see it's looking a little bit shorter. So we've actually managed to move some of the code out. And what we've done here is to create a restaurant repository. So the idea of this is many systems, they have some kind of data store somewhere, right? So presumably you have something like a database, maybe locally, like core data or Swift data or GRDB or whatever you're using. You could be storing user defaults for like who knows, whatever reason. But you have some kind of storage maybe locally, maybe you've got some kind of storage remotely as well. And from my experience, like, it's very hard often. If you have like a team of app engineers and it's like, this sprint we want this thing, you're like, okay, backend should make that change. And it's like, well, there's no backend engineers available, right? And like, you probably can't go in and jump in and do that. So like, you ask an iOS engineer for a solution, like, what are they going to give you? iOS solution, right? So quite often we have very inflexible services that we have to work with, and that's not anyone's fault. It's just often the nature of the game. Sometimes you're fortunate enough to have that. But not all the time. So creating these intermediary layers can help take something from different services or mapping things from different formats and sort of creating something that's like really simple for us, because on the like UI and the view model, we just want, give me a list of restaurants. Like, I don't care where these come from or how they got there. Like, I just want a list of restaurants. So these layers can sort of abstract it. They can talk to different services. You can swap out those different services. You might implement a caching layer as well. So in the app I talked about, that I did the startup, these works really well because it used combine and it had subscriptions. So it goes, give me a list of restaurants. It's like, I already know the last restaurants since you last opened the app. Here it is. Immediately access, here it is. And then it'll go and kick off a request, fetch them. And then as it updates, it'll refresh with the latest ones. So it doesn't care if you've got slow internet, like fast internet or no internet, it'll just sort of work. And you can implement this as a layer where you can sort of tap in and like cache these. So I'm a big fan of these, and they work really well for abstracting all of this out of the UI, but also they can now be shared across different clients. Another example of this as well is on the Listen app, we had a live stream, a stations thing on the home screen. So I had a list of stations, right? And like, I think a lot of people would just go and put that on like the home view model, right? We've got home view and the home view model, put that on there, job done. But the nature of it is that there wanted to actually be shown on CarPlay, right? So if it's in the home view model and it's like heavily integrated and tied into that life cycle, now it's a pain to pull something out small out of such a big screen. But when it's in something like this, then you can use it with a different UI. You know, or like I was saying before, if you had something like, you had a widget, for instance, or you had like a different like iPad app, different UIs can reuse this same domain and business logic. A lot of the time, they often end up quite basic and just act as an empty mapping layer, but I find often they end up changing to be more than that if done well. So here we've got some fetching data. So it tells it, hey, cool, I'll fetch some data. So it goes off and loads it. And again, this is just injected in. So this uses the protocol witness. I won't get into the details of that today, but it uses that. If you're interested in that, I can point you to some materials on that. But that was sort of, I think, introduced by the Point Free Co crew. Which is quite a nice way of sort of handling dependency injection. Very simple way of getting up and running, which works well. And we've got a function here which gives you a restaurant. So this is a function that we lifted out of the view model and abstracted into here with the sort of criteria and sorting. And then we've got, again, all of this sort of code here on the store. So we just now can ask the store, give me a list of restaurants with this criteria. The view model doesn't know anything about the stuff anymore, and we've got sort of like a centralized repository which can act as like a provider of information. It's another term for it. People have all these different names for it. Now the view model can just liaise with that. So, you can see the refresh data. It's just now asked the service to perform the load, and then sort options changed. It's like, cool, sets it, really, really simple. You're toggling it, toggle it. Perform load. It's like, cool, I'll fetch the restaurants and say I'm loaded. Really, really, really simple. And you can see here now this like filter and sorted restaurants, like it just delegates it out. So the idea of this is we want to remove all of this complexity around the view model, and like ideally you have this in, like, you can see a views layer here, and with the introduction of previews, we don't want too many complex services and complex code that we have to constantly compile, because it all slows it down. You want your UI module to ideally just be UI, and where this data comes from, it doesn't really matter, and you're just compiling your UI, and that's all you want to see. So cool, I'll go and add all my data services, I focus on that, cool, build some testing, build up the repositories, awesome. Now I want to build UI, like when I'm setting colors and positioning buttons, like I don't care about where that list is coming from, just give me a mock value. And this pattern works really well because you can see here on the preview, I can provide it with a list of restaurants that, I create the view model and I inject a closure that says get restaurants, right? I can just say, here's a list of restaurants, and it'll show it in the preview, which is really good for sort of being able to build quickly and mock. You don't have to go and create, big complicated services layers for trying to generate a mock preview. So we've gotten that, but we can still see there's some stuff in there. So the navigation, so we can see the navigation was routing through it as well. So what we've done is we've actually just removed that entirely from the view model. And on the view, you can see here that it was having to inject view model functionality to pass down to child views. Same in here as well with creating like the view model for the preview is having to inject these mock services, which isn't fun. And then now we can see this is like a child view. So on the restaurant row, like, UI table view cell or like small view equivalent, you now have access to the environment and you can just call it directly. And that gets injected up at the top level. So you can see in here, we have a navigation service which is stored at the root level, injects it into the environment, and we have our navigation here, which is just a really, really basic. Let me show the full one. That was the same one that was working already, and then this is the new one which just adds the environment key and adds it to it. So it just goes through the Swift UI environment, so it allows any child view anywhere to sort of perform navigation within the app. And now the view model has no concept of it, as I mentioned, fully stripped, which is cool. Another similar one, let's do the same for analytics. So you can see in here in the view model, we've managed to remove all of that analytics code, which is really, really cool. And then in the list view, we've now added the analytics service. You can see we don't need to pass that through. We can just call our analytics directly, because often analytics are tied to view events, like people want to know when someone's navigated to it, when it appeared, when they left it, etc. And that state is often better represented in the UI. And you can see same in our child. We've actually got the sort menu view. We want to know when sort options are changing. So it sort of allows all these different places to be responsible for it, which is quite cool. And again, still quite simple and straightforward to test as well. So going back to our view model now, when we look into it, by delegating some of the stuff like analytics, navigation, the repository and services layer, we've sort of brought in a few different concepts where we're using these compact maps and filtering and sorting operators. We've got very functional style functions now where we sort of give it an input and get an output. You can see this code has suddenly gone from being quite a lot going on from all these different things to now being straightforward, and we lean this into the other areas. So one example or an extension, right, is in this analytics service, we're still calling with analytic events, and passing in different values, but some businesses or enterprises have very complicated analytics, and it's not just a matter of passing a like string value. It's like very complicated and hard to construct. you can have a separate analytics service that handles all that, and then you just go statically typed, sort menu activated or whatever, and then in the analytics service it's got all of the values, and you can have all of the testing to ensure it's correct. And it's like you've like kicked all that over there, you don't need to worry about it, and the view stuff can focus on being a view. Does that all make sense so far? Yeah? Any questions on that part? Sweet. Cool. So, what did we fix? The actual fetching and persisting. View's not doing that anymore. Green tick. Polling of data. That's gone. We weren't doing that anyway, but now it's acting as a centralized cache store. So because that services repository is created when the app launched, if you were to go into that screen and then come back, go back and then go back into it, it's already loaded. It doesn't actually have to fetch it again because it's got a cached value sitting there. Whereas if that value was actually tied to the lifecycle of that view, it would be destroyed and you'd have to fetch it again from the network. So that's the one little thing as well. Analytics gone, navigation gone, UI we didn't touch, that's not what today's talk's on. Complex business logic gone as well. So now if you like look at that view model, there's not really like arguably much to test. It's like you want to reload data, I'll just call the load data function, you know. I want to change the filters, I'll just tell it to like set the filters. And that allows you to sort of like focus on the unit testing, which is testing the unit of code rather than creating like a large view model and having to test the various aspects of that. All fixed. Well done. You've got correct architecture. It's now perfect. We can go home, wrap up, done. Or is it? So your views are just part of it, really, at the end of the day. So a lot of people, I remember when I was getting into app development, and like, do you use Viper or MVC or MVVM or what is it? You know, what's your architecture? I'm like, I don't understand this. Like, what am I missing? I'm like, this views are just like aspects. And I know as front-end engineers, like, that's what we obsess over, the details, the buttons, the UI, but it's just a part of it, you know? Like, it is only a small part. It's like, how do you organize the rest of it? And like, oh, I don't know. Like, there's no like term for it. There's no guidance on it. And it's very hard to get advice from this because, you know, a lot of people that are doing this are giving advice from like their own personal projects, and that is very different to something with millions of lines of code. There's no great resource I could find from it, and the only way I've sort of like found it is to trial and error and learning through it. And that's what working in that agency with such talented people, and they're all trying all these different things and getting all these different flavors and all these new frameworks coming in. Like, remember we'd combine, and then it's like that was like lasted like a year or two, and it's all Swift concurrency now, and the evolution of it, you know, Objective-C to Swift, you know, you got Swift UI, and like it all evolves, and having to stay up to date and adapt. Like, I've done so many new apps, and it's like every time it's completely different to the last, from lessons learned to new technologies introduced. But, you know, like we've got to consider the stores, services, networking. How do we manage persistence? How do we manage SDKs as well? That's a huge one that gets really overlooked. The modules and packages as well, how we organize our code. The dependency graph, so how these modules depend on each other. How we inject dependencies. There's so many different ways of injecting dependencies. All have their pros and cons, but it's not an easy one-size-fits-all. There's some frameworks out there that can help with it. There's some really basic ways of doing it, but, you know, getting that right from the start is quite important. Otherwise, you've got a big mess to clean up. The feature or services reuse, how might this be used? While it might be wanting this today, what might the future behold? Like, is this maybe wanting to be put onto a car's display, for instance? Is this wanting to be a Mac app? Are we wanting to pick this whole media player up and drop it into another app? So sort of thinking, you know, in that fourth dimension with what I'm building now is to achieve this, but how should I do it in the way that might make it easier later on? And white labeling as well, that's quite a common one that sort of sneaks up on you, where you might just have one brand and the CEO goes, we're partnering with other company and now we've got two brands to do, you know, probably what happened here as well. So, sorry, this is too much to go through into detail in all of today's session, but there's like a lot to think about sort of in terms of architecture and building all of these services out and how they all talk together, how they're organized. It's just too much to go into detail into one talk, but I did want to have a look at module dependency graphs. So this has been something that has become more important since previews were around, and it becomes more important as your code base scales. So when it's just you working by yourself, probably doesn't matter too much how it's organized, because you can easily adapt it and change it, and build times aren't going to be an issue. When you have 40, 50 engineers pumping out code like crazy, suddenly it becomes quite important, particularly if you want working previews. Packages. Who here uses Swift packages? Everyone in the room should be sticking their hand up, hopefully. Packages are a great way of organizing your code. So before this, you sort of might have like binary targets. A little bit more complex to manage, a lot of overhead, you had things like CocoaPods and stuff like that. But now we've got Swift packages. They're really, really good for sort of creating remotely stored code or locally stored code, sharing these across different apps and code bases, and even organizing if it's just one app, and even if it's just you doing it, breaking these up into the separate modules is really, really good. So again, don't have the time today to dive into the absolute depths of packages, but if you have any questions about them, feel free to come chat after, and happy to talk on that. But yeah, absolutely would recommend using packages to help organize your code. And what I've found to work pretty well, I did initially start with having multiple packages and then having different modules within them. So you might have a package to say encompass like all of your data services, and a package to encompass all of your UI. But what I've found that's working really well now is to actually go with fewer number of modules, fewer number of packages, and even just having a single package with different modules inside of it works really, really well. You don't have to keep changing between them. You don't have to keep changing and re-resolving different dependencies. You can actually enforce rules between them as well. So yeah, I think actually having that single package, if you can, if it's a local app, is quite cool, rather than sort of over-engineering it. So few ways to organize them. You can either group by domain or sort of by feature. Obviously there's more to it than this, but I sort of wanted to cover two different high-level ways. So grouping by feature, you can see here, you might group by, say a media player, you've got a library, you've got settings, you've got onboarding. And within each of these features, you sort of group by, like, you might have some UI, you might have some business logic, and you might have data. I think this way works really well when you're at very big scale. So think if you've got say a Facebook, and you've got like a marketplace, you might have a marketplace sort of package, and that there has all of these various services inside of it, and you don't need to go and build like the home page, and you don't need to go and build all the settings and everything. You're just like, I just care about this one thing, and you work within it. I think this sort of approach works really, really well. But if you're working on a smaller app, it might end up being a little bit over engineering, because at the end of the day, you still want to have some shared services. So for each of these modules, ideally you don't want to have to go and implement your own database in every one, your own networking client, your own models and mapping layer. You want to sort of have your core network, core persistence, core data, core UI or whatever it is, and then each of these modules can sort of work in isolation alone. And if you're, say, a feature engineer, you can easily go and work through the various stacks to achieve your feature, from the data to UI layers, and you don't have to build like a massive, massive amount. And then you have your audit sort of integration, and it can sort of file through. So this is a really nice way of doing it. The other way is to sort of group it more by domain. So you might have like your UI together, you might have your components, your data, your network, your persistence, your services, stuff like that, and you group all of it together by like relation. This here is also quite a good way of doing it, and I'd say for like most cases, like this is quite a simple way of doing it, because like if you're building UI, it's like I want to just focus on the UI, so you go and open that, smash up the UI, we're like, I want to add like the database stuff, you go and focus on that, and it's all sort of grouped together nicely. And then that means you can abstract these things internally, so you're not exposing all of your networking stuff, you're not exposing all of your internal analytics and stuff. It's all purely encapsulated within that little domain, which is quite cool. So that would be my advice for most people there. So say we want to go ahead with that. Looking at this here, could anyone tell me what the potential problem for this dependency may be?
Maybe having to update 5 different packages when you need to alter the signature?
Yep, definitely. Anything else? happens here is because we have a direct dependency, so we have an app at the root. To build our app, we need some UI. To build the UI, we need to know about the domain. To know about the domain, it needs to know about all the data services. And then the data services may need to talk to other services like API clients or generated sort of stubs like protobuf or GraphQL or something like that. So what actually happens is you end up with sort of like a triangle, right, where the app is a small little bit at the top, and then underneath it is a large amount of code that needs to compile. So when you have a package, and a package depends on another one, it needs to be able to compile that and create the interface for it. And then that will then probably move to the next one, and move to the next one, and move to the next one. So these can't compile in isolation. It has to work sequentially through it. And the issue with that is, say you have a public service down here, and you have 500,000 lines of generated code, and that signature for that module changes, and it's imported in your UI layer everywhere. Suddenly all of these packages now need to go recompile because their inputs have changed. So it needs to go, okay, that was importing it, its public signature's changed, so it has to go and import it. It also means if you want to go and quickly like build a preview and build your UI, well then now you need to go and build all of this other stuff when your UI is not related on your business logic. It's not related to your data, and it's not relating to your services. You just want to like actually see the UI and like build that. So decoupling these as much as possible, where you can sort of work on them independently at scale, is very important. And it doesn't actually take long, to be honest, to get to this being problematic. Like if you had probably 3 engineers working for 6 to 12 months, I think you would probably start to get bottlenecks with previews. Yeah, so very quickly, if you think about a new app, right, you know, you're building it, like most apps are like normally over a year to build or close to a year. So before you've even taken your app live at scale, you've got fundamental architecture problems where, you know, you've got bottlenecks in your workflow. So how do we solve this? This is one way, is going for a non-linear app architecture. So what you actually have is these separate buckets. So you have your app at the top still, we need our app, but you have different layers here, and all of these are in parallel. So UI doesn't know anything about the services, data doesn't know anything about services, they don't know domain, and then you have your core layers down here, so similar to the other one where you're grouping by the feature. You can have, say, like your models, which is your core like data models that are used across the various layers. So you might want to persist something, have some business logic relating to it, and like show it on a UI, right? So in that case, that might be like our restaurant. You might have core things as well, like core like UI functionality, loggers, helpers, stuff like that. And these packages can all sort of like import them, and they can work in separate silos. So what that means is if your UI is over here and some data service or domain service changes, because the UI is not actually importing it, doesn't care. It only cares about what's sort of going into it, and that's how you can inject it in through the app, being a compositional layer. And it also means if you want to, say, do some UI tests or do some UI previews, you're not required to build any of these other things that are completely unrelated because you're testing in isolation. And again, that's what unit tests should realistically be. So does that sort of make sense, building it like that? Awesome. Lastly, guardrails. Guardrails are very important. So as I mentioned before, by having a single package, you can actually enforce these at the package level. So what I did is, you know how you have like strings to do, like I want a module blah, and you put a string with a module name. What I did was create enums that represent these, and then I go, here's an enum for my data packages, here's an enum for my UI packages, for my components, stuff like that, all my various external SDKs and services. And by mapping it as an enum, because again, that package.swift is just like Swift code, you can write any Swift code you want in there. You can then enforce guardrails. So it's like, if I have a data service, here as it is, here's the URL for it, here's its name, cool, it's a dependency, awesome. And then a UI target tries to import it, and it'll actually, when it turns it into the actual string representation, when it tries to compile that package.swift, it'll actually go, nah, fatal, like you can't do that. So that's one form of guardrails. And when you get at scale, like for here at Entain, I think we had probably close to 40 iOS engineers at the peak. It's very hard to get everyone aligned with an architecture or to change an architecture. So being able to put hard stops on it and go, you can't actually do that, is very important. The issue with that that doesn't actually fix the problem, right? So if you are currently like migrating and you say are importing, if I was to go back to here, if say I say we've removed all data dependencies from the UI, right? Cool. I'm going to put a stop on that so UI can't import it, but UI is still importing domain, and domain's importing data. Guess what? You can import it directly in here, and you don't even need to list it as a dependency of it because it's importing a domain layer which knows about the data. So it's like, oh, you want data service A? I know where that is because it's already found domain. Domain's exporting it from here, so you can get it directly. So that's a little gotcha as well, where even saying this cannot be imported, you can still transitively import it. So how do you solve that? Lint rules. So you can apply linter. We use Swift lint, many other linters out there, but they're really good, and you can just carry it like a custom grep and be like, hey, you can't import any of these services. You cannot have the word import data service A within this directory, right? And that can be your UI directory or whatever directory you want. And then when engineers are working and they go, oh, I want this thing, maybe I'm new, I'll try and import it. It'll just be like error. You can't actually do that, and it'll tell them, hey, instead of trying to import the data service directly, you should inject it through layer X, refer to this document, and there's a full generated doc.c guide which sort of walks you through the architecture and data flow and how it all works. And that's a really good way. Like if you can find a way to enforce with a linter architectural decisions, that's generally a good thing because it fails early. Whereas like if someone's gone ahead and built this and they spent 2 weeks doing it and they're like, the deadline's tomorrow's to ship, and then it gets to review and someone's like, that's not how the architecture works. Like you're going to probably have a pissed off product owner, and you're going to have someone that's also pissed off who's just spent 2 weeks doing it. So being able to like fail early is generally a good thing. You can also catch these sort of things in the reviews. Have CI as well that's sort of doing these checks as well. I much prefer to fail early. Like they're still probably good to have there as well. But again, if you can automatically enforce it at the time of typing, like that's the best way. And also remember that simplicity is key. So you can always overcomplicate things, you can always have all this crazy stuff, but at the end of the day, like someone new's coming on, like they're just trying to ship features. Don't overcomplicate it, don't make it too simple, don't over like modularize and make all these different packages and services and stuff. Just try to keep it as like simple as possible. And if you have a really simple architecture, like you can sum it down to something like that. You got like, sweet, these things, like most engineers are gonna be like, cool, I understand that, like awesome. But when this turns into like crazy arrows pointing in all different directions and you got like 200 of these, like no one's gonna be able to understand that in their head, and even computers are gonna be able to struggle to understand it. So, guardrails done. You got some good practices in there. You've got some modules to sort of help organize this code. You've kicked some stuff out from the view models. You've organized it appropriately. They can now all be independently tested. They're not interdependent modules on each other. You can now build your UI without worrying about the rest of the app. You've probably got a good foundation to go ahead and scale to millions of lines. So thank you very much for coming tonight. Hopefully you got something out of that. And you're welcome to connect with me. I don't have a Twitter or whatever, I don't really use it anymore, but maybe a LinkedIn maybe if you want. I'm happy to connect with you on there and answer any questions. Otherwise, I'm here every month, or you can find me on the Cocohead Slack as well. So thank you all for coming. Did anyone have any questions on that at all? Anyone facing any architectural problems they wanted a hand with?
Probably just a comment, like on
Yeah.
packages. Like you don't just a comment on packages. You don't have to think of them as a package per repo. Like you can have local packages within, like maybe the main apps project. So,
yeah, absolutely.
Yeah. You don't have to have all the overhead of your spinning up a new repo.
Nah, not at all. Yeah. They're quite good to have them remotely if you want to share them across like different code bases. So say like ABC, we have very similar experiences across things like the various apps, right? So having remote packages is a great way of being able to share these across multiple Git repos, because we say have like analytics services, and you'd have say media player and stuff like that, and all the apps can inherit these and they're sort of maintained as an SDK level. But within your own, like say application A, having it as a single package and having it checked into the repo and using it as a local package, that's the go. Because otherwise you've got to deal with like I have to go and raise another merge request in another repo and another code base, wait for approvals, deploy a new version, tag it, upgrade it. It definitely adds a friction. So if it's going to change frequently, I would try avoid it. And you can also use submodules as well as a way to sort of circumvent that, where you can sort of keep that within the code base, but you can still remotely have a reference to it if needed to be used elsewhere as well.
Yep, cheers.
So, anyone got anything else they want to ask?
I've got one.
Yeah.
When you're introducing yourself, you've got quite extensive experience across different code bases. I guess for my question is, how you got to where you are now, what's sort of been some of the trickiest code bases you worked on before?
Ooh. Probably like some of the startup days, I think. Working on them where, you have a collection of people, like those sort of companies where people come in, they're a contractor or they're new to programming, they do 6 months and they move on. If you've had someone lead or someone sort of steering the ship and they've been steering the ship for a long time and things are consistent that way, I think they're a lot easier to understand. But when you have someone come in for 3 months, 6 months, and they're like, I'll start doing it this way, and you start doing it that way, and you start doing it that way, and there's like 20 different ways of doing things, it's really hard to sort of go, how do you align that? Whereas if you have a centralized way of doing things and you want to migrate to a new system, you can easily deprecate that and walk through the new one. So I think those code bases where there's been frequent changes in staff has been the hardest to personally manage. Yeah, awesome. Good question.
Since you mentioned about working in startup, sometimes in a startup the requirement or the need is not clear yet. How do you architecture when you don't know? Like it's easy when you know all the feature and their relationship and build architecture. What about the opposite? Like when exploring phase, not sure about what the feature will be. How will be? Do you have a good approach to architect this kind of? Yeah, absolutely. It's a great question.
I think, again, this comes back to not over-engineering and being able to move fast and fail quickly. So having a very simple, easy to work with code base where you can quickly prototype things, experiment, you can delete, you can fail is quite good. Using data to drive decisions is fantastic, right? So speaking to a recent experience I went through, they went through a rebuild and they went through sequentially. This is the order in which we're doing it because that's the order it appears in the old app. But then time came, we have to release, right? But then there's like all this core experience is missing and hasn't been built, and all the stuff that's not actually used is being built and is perfect and is tested, right? But had they gone with a more data-driven approach, what they would have found is that people actually really care about this, this, and this. All that other stuff that we spent months on, like that can come in another version. Like that's not even important. So using data to steer it, and like it could be even as simple as like having a button, right? And it's like, say, a sleep timer button, right? And you haven't built a sleep timer into your app, but you tap that and you go to the screen and it goes, we're still building this, please check back in a future update. Bang, tap in some analytics to it, and you can like, okay, no one's actually tapped that button, or like, God, everyone's tapping that button, like, and you can use that to help steer it, because building software is very expensive, and when we build software and we get in customers' hands, we want it to ideally be right and working, particularly when you're handling that sensitive data. So being able to justify that investment, particularly at a startup level, is key, and particularly if you can tie it back to revenue as well for the business is even better.
Do you have like a preferred navigation pattern? Like it's one of those things that always just seems to be more difficult than it has to be.
Yeah,
so,
definitely. Using navigation stack, if it's iOS 17, I believe. iOS 17? 18, 17. I think it's 17. That would be my preferred way of handling it. For a smaller app, you can use something like that. You could even inject, say, like a router into the environment, similar to what I did with those analytics services. That can then call up to it, and then it has sort of like, manages like a URL, and you sort of have your slugs, your path components, and you can sort of like push and pop things off from it. And that sort of grants access to everywhere, but it gets more complicated if you sort of go with the architectures where you have like features independently, because that feature doesn't know about the other features, so it can't navigate to them. So then you sort of need to implement like intermediary layers in the app to sort of like manage those cross-cutting features. But where you sort of have, say, something like, say you had onboarding within a package and it's all sort of self-contained, you know, you might enter an onboarding flow, like go through 10 screens and then you sort of like exit the flow. They're really nice to sort of self-contain within those packages, you know, and you can sort of have its own subsystem of navigation where it can do it. But if you have, say, like a media player and there's like 20 places you get to this media player, that might sort of live more at like the app layer, right? And you can sort of like just ask that and it'll go, okay, media player, I, you know, present that or I push that, however it works, similar to a traditional coordinator. But the issue is sort of when you go and you sort of have these traditional coordinators and then they're injected down the view models and then the views are trying to create other views, but then it doesn't have access to some of these things that, yeah, it gets messy. But yeah, I think SwiftUI is sort of given away with some of the traditional coordinator level. One thing to bear in mind though is that state on parent views invalidates view trees. So imagine you have a navigation stack of 10 screens. If on the first screen or at a higher up parent that state changes, it invalidates everything. And the UI may not change, but the state's invalidated and it needs to traverse it all. So, you know, if you had, say, like a polar on your app root and it was firing every second, like it's invalidating that whole tree every second. And that can be quite expensive and lead to severe performance issues. So where you go back to actually having SwiftUI, but it's nested within a hosting controller, you're isolating that SwiftUI redraw to just have an impact within that one particular view controller. So when you have lots of things going on or you're migrating, like that might be a more preferred approach of taking it, where you sort of take like the SwiftUI plus a coordinator approach as well. Cool. Any last questions? Sweet. Oh, might wrap up there. Thanks all for coming.